Hello everyone, thank you for joining us today. Today we're going to be reviewing Cloud 101, AWS Overview for Education. My name is Mike Kuntz, and I'm an AWS Senior Solutions Architect covering education. With me in the webinar today is Will St. Clair and Jay Vagalatas, who are doing moderation for the Q&A today. You'll notice off on the side you have a Q&A session there. Feel free as we go through the webinar today, ask questions, they'll respond to you. We'll also have a Q&A session at the end of the webinar. So starting off, the first question that everybody asks, what is the cloud? It's the on-demand delivery of IT resources over public or private networks, zero upfront costs, no long-term contracts, and pay-as-you-go pricing. Breaking down each of these pieces, we look at how do you get started? Is there a commitment? Are there fees to get started? The answer to those questions are no. To get started with AWS, and we cover this at the end, you go sign up for an account, log in, and you can begin to start using resources as you need them. Those resources range from virtual machines in the cloud, storage, database resources. When we look at that pay-as-you-go pricing, a very easy concept that I like to describe to my customers as we start off talking about this is the idea of a virtual machine. A virtual machine in AWS Cloud running on EC2 or Elastic Cloud Compute, 2 CPUs, 8 gigs of RAM, 10 cents per hour in the US East Northern Virginia region. If you run that server for 10 hours, it's $1. 10 hours times 10 cents, it's $1. The other 14 hours out of the day, if you turn it off, you're not paying for the compute resources for those servers. It really changes how you start to look at capacity planning, utilization, and workloads in your operations. AWS has been in existence since 2006 when we launched our first service, AWS S3 or Amazon Simple Storage Service. In that time, we've amassed over 7,000 education customers and continually growing. A lot of these customers are familiar faces and names that you know. Personally, I've had the pleasure of working with some schools on the East Coast, such as Carnegie Mellon University and others. We have UMUC, who's doing mass deployments of our virtual desktop as a service workspaces, offering to give students across the globe access to their courses. Work with Baylor College of Medicine to create DNA nexus and genomic sequencing, storing that data in S3 and then doing processing. Even schools on the other end of the spectrum, from K-12 and community colleges. You'll also notice there's a large amount of ed tech customers in there, and we refer to ed tech as the customers, maybe public companies that serve educational customers. Some of those customers, ed tech customers such as Ellucian, Blackboard, Echo 360, and Instructure, names that you're probably familiar with. Typical cloud deployment methods for higher education that we see break down into two general categories. The first one are software as a service or SaaS applications. These are software services hosted on AWS services that you use for your workloads. The second option, cloud infrastructure, the actual standing up of servers, storage, and infrastructure services within AWS on our platform. So even if today you're not a customer directly using our cloud infrastructure platform, chances are you're using a software as a service or platform as a service solution through an existing customer of AWS's. Some common use cases for higher education that we see. The first one, dev test. We see in several environments dev and test. Second use case for higher education, storage. A vast majority use our storage services on the back end to increase their utilization of the storage platform. For higher education, we see disaster recovery. This is another very common use case that we see customers going through and doing. Several different ways that customers will approach this for disaster recovery. The first is utilizing existing backup software to get rid of tapes. So using your existing backup software, Commvaults and Managnet Backup and a host of others, instead of backing up directly to disk or tape on premise, you can point this software to point to Amazon S3. removing the need for costly tape maintenance, duplication, and off-site vaulting to third-party vendors. Here you can actually take your backups directly to S3 and then retrieve as necessary. Another use for disaster recovery that we see a lot of customers go through and use, secondary sites or failover sites. In a large majority of instances we see across schools and higher education that are working on, maybe they don't even have a disaster recovery site, one common pattern we do see emerge, a disaster recovery site that's only on the other side of campus. And while that's great help for the primary site if there's an issue with the power there, generally in the event of a catastrophe or an outage, a cut fiber line, being on the other side of campus isn't always helpful. We have several customers in higher education that are utilizing AWS to be their disaster recovery platform. Additionally, since these resources are on demand and only pay as you go, you're only paying for them when you use them. So in the idea of taking a 2-3 tier web application and database, you don't need to have that up and running in AWS for a DR scenario. You can actually go through and turn that on when you need it. And since you're only paying for what you're using, your capital expenditures for disaster recovery edge towards zero. Fourth common use case we see in higher education is around big data. It's an emerging trend and across several research institutions, medical institutions, the ability to collect and make use of all of this data that we're producing. Mentioned Amazon S3, the simple storage service before. We see customers moving terabytes of data per day into S3 to then go and do analytics on top of them, whether they're using our compute platform to do deep learning, machine learning analysis, or use some of the analytics tools such as Redshift, Athena, and QuickSight that we offer through AWS. And finally, another common use case that we see in higher education is around enterprise applications. The traditional off-the-shelf software that customers are using today in their data centers environments, you can pick up and move to AWS. If you can run an x86 workload on-premise, chances are you're going to be able to run that on AWS. Windows, Linux platforms are supported. We have customers going through taking advantage of piece-by-piece migrations of these enterprise applications into the AWS environments, or doing wholesale migrations and getting out of the data center business. Some of the ways that AWS helps transform education. The first one is time to results. You can access this infrastructure in minutes. When I talked about the example EC2 instance, 2 CPUs and 8 gigs of RAM running on Linux or Windows, these instances are available and start up within minutes, so you can go and start working. Another thing in this time to results is also time to science. We have a large research community that we serve out there, and the ability to get in, create an HPC cluster using thousands or millions of cores within a very short amount of time, do your work, and then turn it off, is really changing the way that researchers are approaching the compute capacity. Instead of going to a traditional HPC cluster where you need to sit and wait for queue time, you can go to AWS, create a personalized cluster or a shared cluster among other researchers, go through, run your workloads, and then when you're done, turn it off. And that's it, you're done. There's no more bill to pay as a result of that. And that goes back to the low cost, which is the second thing in how AWS helps transform education. This pay-as-you-go pricing allows you to be very effective on your utilization of your compute and storage resources. By nature, the cloud is elastic, so it allows you to easily scale up and remove capacity. And when I talk about scaling, which is the sixth one that we have down right below elasticity, two ideas here of horizontal and vertical scaling. The idea of vertical scaling is something that most people are used to in a data center and a server-based on-premise environment. You have a server, it has 2 CPUs, and it has 8 gigs of RAM. If you want to vertically scale that, you generally have to get more CPU or more RAM into a physical server. And we offer the option to do that. You can go from our smallest server of 1 CPU and a gig of RAM all the way up to our largest server, which has 128 CPUs and 2 terabytes of RAM. This is known as vertical scaling. However, in a lot of cases where we help customers is to look at horizontal scaling. The ability to add multiple servers in parallel to do that same job. A very common use case there is around web servers and websites. If you think of the idea of a website with web servers in the front and a database in the back end, You could potentially go and make one web server much bigger, but in a lot of cases it actually makes sense to add in a second or multiple web servers to help scale that load. The way the pricing is done on AWS is we don't incur a penalty for having more or larger servers. The idea of the one that I talked about, 2 CPUs, 8 gigs of RAM at 10 cents an hour, if you double the size of that server and make it 4 CPUs and 16 gigs of RAM, it would then be 20 cents an hour. Or if you do 2 of those servers, which still gives you the same amount of effective CPU and memory capacity, it's still going to be 20 cents an hour. So you begin to look at how easy it is to do horizontal scaling. AWS, the platform's globally accessible. I'll talk a little bit about regions here coming up in future slides. And then the most important one here that we have is security. Security is the #1 priority for AWS. With all these things, it allows you to focus on your core mission. So it lowers the time that you spend building and maintaining infrastructure, and you can actually concentrate on new learning initiatives. You can concentrate on the research that you're doing. You can focus on the core concept of serving students. We're going to go run through a bunch of common myths that we've seen over the years of doing this when we talk to customers. The first myth is the cloud isn't secure. And that was a common question that we had going back to 2006 when we started. And we find now that security is actually the driver. More and more we have customers coming us believing and saying that they would be more secure in the AWS environment than doing that on their own. We have a quote here from Tom Soderstrom, CTO at NASA JPL. Based on our experience, I believe that we can be more secure in the AWS cloud than our own data centers. For a statement from NASA's Jet Propulsion Laboratory to say that, it's an amazing thing, the ability for us to go and say that to our customers. And this is, not even just in the public sector. We see this in finance, several other verticals where customers are now relying on the security of AWS to drive them to move forward into that platform. And we do this on several fronts. We have over 50 global compliance certifications and accreditation. Schools that are looking at, we have white papers to outline FERPA compliance, individual mandates. If you want to go and do HIPAA workloads, do PHI, we sign BAAs with customers, and we have great white papers and resources to help customers with that. A hot button topic for education right now is around NIST 800-171. If you have a school that's looking to figure out how to meet NIST 800-171 compliance by the end of the year, AWS offers several quick starts that we'll be able to go through and leverage and use. As part of the follow-up from today's webinar, we'll send out links to those URLs where we've done webinars. Whether it's quick starts in the enterprise accelerator that AWS has or the need to pull in a partner who's familiar with these workloads, we have several resources to help you meet those compliance needs by the end of the year. It also, running on AWS, you have access to a deep set of cloud security tools. From virtual private cloud, which is the networking Finally, finally, around compliance, we have several tools to help customers. The first is CloudTrail. CloudTrail is a service that you can enable in your AWS account that will allow you to go through and log all actions, API calls that a customer does. So if you go into the console and you start an EC2 service or terminate it, or through the command line interface or several API calls and SDKs that we have make available, this information is logged into CloudTrail. Myth number 2, the cloud is more expensive. Some of the on-premise cost drivers are hidden. When customers go and they look at starting to use AWS, there's a total cost of ownership that people look at. The first one that is commonly overlooked is labor. How much are you spending to maintain your environment? And a lot of services within AWS, we're helping to maintain those environments, so that labor workforce number can now shift to other core missions that you're doing. Networking is another cost that's hidden, and a lot of times across the university or school, this is subsidized by maybe a central IT department or another entity. But when you look at the need for capacity growth, how much bandwidth do you need? This is something that AWS has readily available. For example, if we look at the last published numbers that we have from one of our distinguished engineers last year, in our Northern Virginia region, we'll sometimes see traffic workloads at 125 terabits per second. It's just an enormous amount of bandwidth that we have available for our customers to go and utilize. Customers that are connected to Internet 2, for example, have the ability to take advantage of peering connection that Internet 2 has with AWS on East and West Coast regions. Another cost driver that's usually hidden is capacity. What is the cost of over-provisioning for peak capacity, or the cost for under-provisioning, aka having an outage? Another cost driver that's hidden is power and availability. How much work is needed to be done to keep power and availability to a data center or a network closet? What are all the pieces that need to go into it, the capital expenditure, the ongoing maintenance of UPS batteries and other resources? And finally, space. What happens if you run out of space in the data center or your networking closet? I'm going to take a slight pause here. We were having some audio problems. Want to make sure that everybody is able to hear now. We saw everything for the audio problem should be resolved. However, in the Q&A part, if you're still having any audio issues, please feel free to drop a note in there and let us know. Apologize for that. Talk about University of Notre Dame. They have an aggressive mission to essentially get out of the data center business. In the first year, Notre Dame looked to save over $1 million in costs just around data backups, and they continue to grow and see these cost savings. They're able to easily go and scale up their IT infrastructure as needed, and then also as important, shrink it back down when it's not needed. Everybody that's on this webinar today can probably identify spiky workloads where they have to go through, whether it's the start of a semester, end of a semester, if it's a researcher that has a job that needs to be done, workloads that need to be run, and you need to have increased capacity and demand. The way you do that today is you get the capacity that you need, try to over-provision, maybe by 20%, and then hope you don't go over that. Using the power of AWS and the elasticity and scalability that we offer, it allows you to scale up and then decrease as needed. Myth number 3, I lose control of my applications with the cloud. Here's a great example of the opposite of losing control and actually gaining performance and uptime. We worked with Villanova University to move the website over to the AWS platform. They worked with a partner to go through and do this. They've seen performance and uptime improved remarkably and haven't had any noticeable downtime since 2012. A great example of elasticity and scalability that they saw was 2 years ago as a men's basketball team was going through the NCAA championship brackets. They saw a noticeable increase in traffic to their website every time Villanova won and advanced up through the brackets. At the end, when they won the championship, they actually saw an increase from 15,000 to 200,000 hits to their website immediately. Since they were running on AWS, they were able to just scale up. They didn't have to go and provision anything. They didn't have to do anything. They configured it to scale up and to grow to meet and based on demands. Afterwards, website traffic died back down. The environment scaled back down as well. So they were only having to worry about pay for what was being used, and they were able to scale up. In a lot of cases where we work with customers that try to do this in an on-premise environment, there comes a point in capacity planning and growth where it's just tough or impossible to do on-premise. If you think about the case where you get a massive flash of traffic like this, a school that has a big win, maybe a post on Reddit or another social media platform that drives traffic to your website. If you don't have the capacity to meet on-premise, what happens is you incur an outage. And that's almost as bad, or if not worse, than having the traffic to begin with. Myth number 4, the cloud does not impact the learning experience. We hear this one occasionally, and it comes up. It does impact the learning experience in a positive way. I'm going to talk about a couple customer use cases we have here. The first one is University of Maryland, University College. They've implemented cloud-based desktop and distance classrooms. They use Amazon Workspaces, virtual desktop as a service that we offer for students globally to go and access their applications anywhere. The client services work with Mac, PC, and a host of other devices such as Chromebooks and iPads. There's also an HTML5 client that users can go through. They go to a website and they can log in remotely to these desktops. It provides a Windows 7 experience and also gives customers the ability to bring their own desktops. So if they want to do a Windows 10 environment, for example, they can go through and do this. UMUC has gone through and integrated this into the classroom. It's an incredibly reliable system that they now have distributed across multiple areas. And it allows students from anywhere to go and access, whether they're global, whether they're in a coffee shop. They've seen a 4-time increase of their utilization, and the number of their students that are moving to the platform continues to grow, targeting basically by the fall of this year 10,000 students with over 340,000 hours of student usage. These are some incredible numbers when we look at how they've gone through and grown the platform and helped student engagement. Think about having students effectively engaged for an hour of a work week out of a month. It's pretty impressive to see. Next customer we'd like to talk about a little bit here is Cornell University. Worked with Jeff Christian at Cornell University to do a pilot of a business intelligence course. They also used Workspaces and RDS, which is our relational database service. It's a managed database service where Amazon, AWS will take care of the underlying operating system and database platform. What they did in this class was they went through, created an Oracle database running in RDS, had the students each provision to a workspace with all of the tools that they use. They use Warescape, a couple editing tools, and Tableau. The students would then, at the start of class, when they were provisioned these workspaces, they would go and log in, and they could just immediately hit the backend database and start writing queries for the data warehouse, looking at schemas and how to go through and design this. It really changed the model for how this class was originally perceived to be taught, because at the beginning of the class, how do you get students database access? How do you work through with 20 to 50 students on how to do the installation of all of these software packages that are required? What they did in this model was they had students on day one ready to go and start learning. They didn't have to go through and spend hours of TA and professor time to figure out how to do application installations on their Macs or their iPads or other tools that they had to go through. The other thing that was really important for them, since they had the ability to use workspaces remotely, they didn't have to go
go to a lab to do this work. So when you look at, a place like Ithaca, we had made the joke with them at the time, in a snowstorm, this is great. It snows a lot in Ithaca. If there's a foot of snow, students don't have to worry about trudging across campus in the snow to get to a lab, right? They can do this from their dorm. They can do this remotely. They can do it from a coffee shop. They can get in and actually start to do this work. And the amount of time that it takes to maintain this significantly